Hi, good morning everyone. I hope you are all well. Yesterday we started to look at how the place value of a digit is affected when we multiply it by 10 or a multiple of 10, and we also started to consider how we can use existing knowledge of times tables to help us solve larger multiplication problems. One of the things that we could use to help us, and we've seen this before, is something like this multiplication square, which is attached to the class page. You can use this if you are stuck, say for example, on your 8 times tables, and you can always refer to this multiplication square to help you when solving a problem. Today's lesson is a consolidation of previous lessons to help ensure that you really understand the concept of multiplying by multiples of 10. Yesterday we began to consider how using our existing knowledge of multiplication can help us when solving number problems, which involves multiples of 10. So example, how can my knowledge that 4 multiplied by 4 is 16 help us when we're solving a problem that involves a multiple of 10, in this case 40 times 4. We discovered that because we now know that the place value shifts, because when we're multiplying by a multiple of 10, and we can see here that 40 is 10 times larger than 4, that we will end up with an answer that is also 10 times larger. So in this case, the answer was 160. Remember that when you're solving a problem like this, if you are not confident with your times tables yet, you can use the multiplication squares to help you, or you can draw an array. So an example would be if I was going to solve, say, 3 multiplied by 6, I would do my 3 rows, and then I would have 6 columns. My rows and my columns would be equal. There's my 5th column and my 6th one. And there would be 3 rows, 6 columns. The value of each of these would be 1, which you are more than welcome to mark on, but you don't have to if you can remember that the value was 1. And then you can add them up. You either count them individually, or you could count them in groups of 3 or groups of 6. I'm going to do groups of 6. 6, 12, 18. So I know that 3 times 6 is 18. I can then, if I've been asked to, use my array to also help me solve what 30 times 6 is. This time the value of each of my counters will be 10. So once again, I will draw 3 rows, but the value will all be 10. And I will draw my 6 columns. I can label them all once again if I so choose. I won't finish them all off today, but you can do if you wish to at home. 30 times 6, I can either count them in groups of 60, groups of 30, or I can even count them one at a time. So in this case it would be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, and 180. Here you should notice that the answer is a multiple of 10, just like the question involved a multiple of 10. And if you'd used your previous knowledge, you would notice that because this is 10 times, in terms of the question, the answer will also be 10 times the size. So 180 is a multiple of 10, and it's 10 times the size of 3 times 6, the answer, which is 18. So here, if you knew the answer to 3 times 6 was 18, you can use that knowledge to solve a problem such as 30 times 6 is 180. Remember, we don't teach you the 30 times tables. We expect you, as you're going through school, to begin to learn that you can use your previous knowledge, your existing knowledge, to help you solve problems such as this one. Today, I would like you to complete the questions that you will find on the class page. just below this video. The questions are very similar to yesterday, but as I said before, I just want to make sure that you really have a good understanding before we move on to more complicated two-digit number problems. Once you complete those questions, you have a challenge question. And once you've done that, I'd quite like you to look at the lesson objective, which you'll find on the page. Also, I'd like you to mark off your success criteria. So do you feel that you've met today's success criteria? Best of luck. See you tomorrow.